All right, welcome to Tuesday's lesson. You should have your warm-up, notebook, Chromebook, and the note sheet that I handed out yesterday. All right, warm-up. Number one, we're comparing 8.5 quarts of oil to service 3 machines. We want to find out how much oil per machine. So we're going to start off with our ticket. We're comparing quarts to machines. Our given ratio, well, it's in the same sentence. 8.5 quarts services 3 machines. Converted 8 times 2 plus 1, 17 over 2 over 3, or 3 over 1. And now they want to see how many quarts of oil per one machine. We'll cross multiply 3 times x, 17.5 times 1, and we'll set up our equation. 3x equals 17 over 2, divide each side by 3, off to the side. I rewrote the problem, keep, change, flip, keep 17 over 2, division becomes multiplication, 3 over 1, 1 over 3, 17 times 1 is 17, 2 times 3 is 6, and it's okay to express your answer like that without a calculator. Number 2. A right triangle. Right there, they're trying to tell us some information, a 90-degree angle. And another angle, so it has 2 angles here. One is 90 and one is 40 degrees, and we want to know what is the third angle. So what I did to start this problem off is I drew my triangle. I labeled a 90, I labeled a 40, and one that I'm solving for, I put in a variable. I know that triangles add up to 180, so I could say that x plus 190 plus 40 is the same as that triangle. Combined like terms, 90 and 40 makes 130. 180 minus the 130 would mean that that missing angle has to be 50, and that makes sense because 50 plus 90 plus 180 gets me back to, 50 plus 40 plus 90 is 180, which makes that a real triangle. Number 3, another ticket problem using scale factor this time. They gave us the scale in the beginning of the problem, inches compared to miles. 1/8 inches is really 4 miles in the real world. And we want to see on the map how far apart would 16 miles, 2 cities be that were 16 miles apart. So again, starting off with the ticket, comparing my units, inches to miles, setting up my given ratio, which is my scale, 1/8 to 4. Then plugging in 16 miles in the bottom because that's where my miles are, and I don't know how many inches that would be, so that's what I'm solving for. Cross multiply, 4 times x, 4x, 1/8 times 16, and the calculator is going to say 2. 2 divided by 1/4, or 2 divided by 4, 1/2. Last question, number 4. We have 19 minus n. I need to get this negative n by itself, so the first step is I got to subtract 19 from both sides. 18 minus 19 is -1. Negative n is the same as -1, but I need positive n, so I need to divide each side by -1 to get that isolated. That'll cancel out my negatives. -1 divided by -1 is +1, and that makes sense because 19 minus 1 is 18, and that's where we had to get back to. Okay, today we're picking up where we left off. Again, first off, make sure you know your formulas. So right next to each one, just go ahead and copy it down. Scientifically proven, the more you write something, the easier it is to be remember. Remember, when you get your cheat sheet or your scrap paper at the end of the year for the EOG, make sure you're putting at bare minimum these 5 formulas down. You can add to it a number line, probability stuff, keep, change, flip, anything that might help you remember something later in the test. As far as today, we're going to look at a little bit of, we did some independent single probabilities. Today we're going to do some complex compound probabilities. We just want to take a think about, would these problems down below be a single event because there's only one probability, or a compound probability because there's more than one event? Well, let's take a look at what we have here. Rolling a number greater than 3 and flipping tails. So we have 2 things going on here. We have rolling a number and flipping tails. So this would definitely be a compound probability. Second one, choosing black and then choosing red. Well, again, I'm choosing 2 separate colors. So I'm choosing black first and then red. So again, another complementary or compound probability. Rolling a number greater than 3. Well, there's only one thing going on here. We're trying to just roll a 3. So that would be a simple event. Flipping 3 heads in a row. I'm going to flip the coin, I'm going to flip the coin, and I'm going to flip the coin again. So they're talking about doing something more than once, so that would be compound. Choosing a red, not replacing it, and then choosing a yellow. Well, I'm choosing red, I'm not putting it back, and then I'm choosing another color, yellow. So again, that would be compound. And the last one, choosing black or red. Well, I'm trying to choose either a black or a red marble, but I'm only taking one marble. It's either going to be black or red. So that would be a simple probability. Okay. So again, knowing the difference of when I just have to find one event versus when I have to find more than one event and multiply. All right, a little bit of extra notes. Theoretical probability, compound events. Compound events consist of 2 or more single events. So again, this is where more than one probability is coming into play. And how we find the probability is the probability of the first event times the probability of the second event. So anytime we have more than one event, we're multiplying each event times itself. There's a BrainPop video here. You're more than welcome to go to BrainPop and look up compound events. If you need the username and passcode, just raise your hand during class and I'd be more than happy to hook you up with that. All right, as far as today goes, I'm going to model a couple for us. So what is the probability of getting a 2 on the first spinner and a 2 on the second spinner? Well, the first thing is there one event or 2 events here? Well, I have 2 spinners and they're each getting spun, so that's going to be more than one event. So I know it's the probability of the first event times the probability of the second event. Well, let's look at the first spinner. I want to get a 2. Well, there's 1 2 segment out of 4 segments. So I would know that I have a 1 in 4 chance of getting a 2. On the second spinner, it's the identical spinner. Again, there's 1 segment that's 2 out of 4, so that would be another 1/4. And again, anytime I have more than one probability, I am multiplying 1/4 times 1/4 would equal 1/16. Okay, so again, we find the probability of the first event, we find the probability of the second event, we multiply the 2 together in a calculator to get our correct answer. Another one, this one dealing with a menu. So it says down below we have a choice from a dairy, a fruit choice, and a toppings choice. Well, let's look at what the question has here. What is the probability that Joey's shake will be made of ice cream, pineapple, and granola? So it looks like he wants to choose 1 dairy. Well, I have to look. I have 1 ice cream out of 2 choices. And then he wants a topping. Well, there's 1 pineapple choice out of 3 choices, so that would be a 1 in 3 chance. And then he wants granola as his last topping choice, and there's 1 granola out of the 2 options. Well, again, we want to know what's the probability that he gets one of those things from each section of the menu. Since they're compound, I've got to multiply 1/2 times 1/3 times 1/2, and a calculator would say 1/12. So again, probability of the first event times the second event times the third event in a calculator, fairly simple. One more I'll model. In a jar, there are 8 peanuts, 12 almonds, 6 walnuts, and 10 cashews. All right, well, first off, there's no picture, so I need a strategy. So let's go ahead and write. I'm going to put 8 P's for peanuts. I'll go ahead and put 12 A's for almonds. We have 6 walnuts, so 6 W's. And 10 cashews. Okay, now I can take a look at what they're trying to actually ask me in this question. Because once I have a strategy written down, the math really is not that hard. What's the probability that they reach into the jar, pull a peanut out? So let's take a look at the first event. Well, I have 8 peanuts, and I have to figure out my total. So I know that I have an 8 over, well, let's think. 12 plus 8 is 20, plus 6 is 26. 26 plus 10, 36. So we know we have an 8 in 36 chance of getting peanuts. Well, now, if I keep reading, it says he takes the peanut and he does not replace it. So I got to get rid of one of these peanuts. Then it says, what's the probability that he chooses an almond? Well, again, I can look. I have 12 almonds. But now I have to think to myself, if they took that peanut out and he ate it, and he never obviously didn't put it back in the jar, how many almonds or how many things are left? Well, you started with 36, but we took one out, so now there's only 35. Okay? So again, all I did, draw a strategy, think about, well, what's the probability of the first event? But we have to read carefully because he did not replace it. He ate it and did not go back in that jar. And then last step, we had to find out how many almonds. Well, I had 12 almonds, but now I only have 35 left. Last step is to put this in a calculator. So 8, 36 times 12, 35ths would give me 8 out of 105. 8 over 105. Okay. So again, reading carefully, using a strategy, interacting with the problem makes these probability questions really easy. Turn your Bitly. I would try a couple of these on your own. That way you can ask for help if you need before you get into your grade today. So I'll give you, take about 5 minutes and then pause this video and then unpause it when you feel confident that you want to try out your answers. All right, if you're ready to go, here we go. What's the probability that a student is flipping tails 3 times in a row? Well, I know that there's 2 options on a coin. We have a head side and a tail side, and I want to get tails. Well, the probability I get tails the first time, 1 out of 2. There's 1 tails, 2 sides. Then I flip it again. Still only 1 tails, still only 2 sides. And then I want to flip it again. Well, there's still only 1 tails out of 2 sides. 1/2 times 1/2 times 1/2, 1/8. Second one, John is rolling 2 number cubes. Okay, so I have 2 dice here, labeled 1 through 6. Well, first thing, I probably want to draw some dice out. 6 numbers, 1 through 6. It says, what's the probability that he gets a number less than 4 on the first cube? Well, the first cube, less than 4. 1, 2, 3. 3 out of how many? 6 numbers. So I have a 3 in 6 chance of getting a number less than 4. Now, we're going to multiply that times. He gets a 5 on the second one. There's 1 5 on that dice out of 6 choices. Again, I put this in a calculator. 3 6 times 1 6. And I would get an answer of 1/12. Again, using a strategy, reading carefully, seeing if there's more than one event, multiplying in a calculator. And last one, before we get into the graded part of the day, Mark can choose between Pepsi or Coke for his drink. So we have 2 options for a drink. He can choose pizza, tacos, or chicken for his dinner. So he has 3 dinner options. And then he can choose a cake or a pie as his dessert. Well, let's see what kind of problem we're dealing with. What's the probability that Mark chooses tacos? Well, we have 1, 2, 3 choices for entrees, and one of them is tacos. So he would have a 1 in 3 chance of getting tacos as his entree. Then it says, with a Pepsi. Well, to get a Pepsi, there's a 1 in 2 chance of choosing Pepsi. Again, it says and pie. Well, again, dessert options, I have 1 pie out of 2 options. So again, 1 out of 2. 1/3 times 1/2 times 1/2 would give me 1/12. Okay? At this point, make sure you have all your notes filled out. If you got to go back through the video and copy some stuff down, you're more than welcome to. Today's Bitly is on your paper. Go ahead, you can either use a separate sheet of paper or you can just fill in the work underneath the Bitly name. Okay? At this point, pause the video because tomorrow's lesson is coming up next. All right, welcome to Wednesday's lesson. Same deal, warm-up, notebook, Chromebook, and the note sheet that I gave out on Monday. As far as the warm-up goes, let's take a look. John is working on a new machine. We're comparing 2.5 hours to master 1 1/3 of a machine part. So again, we're comparing hours to machines. Our given ratio, well, I have to convert. 2 times 4 is 8, plus 1 is 9. 9/4, 1/3 of an hour. 9/4 of an hour, 1/3 of a machine. Then we want to find out how many hours would it take to complete the entire machine. I'm going to start off by cross multiplying. 1/3 times x, 1/3 x. 9/4 times 1, 9/4. Divide by 1/3 on each side to isolate x. So my division problem, 9/4 divided by 1/3. Keep, change, flip. 27/4 is the correct answer. Number 2. 2 angles are supplementary. Well, I know supplementaries form a straight line. One angle is 30 degrees, the other angle is 2n plus 10, and we want to solve for n. So the first thing I did is I drew out a picture. Put 2n plus 10 on one side, 30 on the other side of my straight line. I know that these 2 angles add up to 180, so I could say 180 is the same as 2n, positive 10, positive 30, positive 40. From there, easy 2-step equation, subtract 40 from both sides. 140 is the same as 2 times n, so I have to divide by 2, and I'd find out n is actually 70. Number 3, we have another ticket problem. This time, we're comparing inches to miles. So that would be our given ratio, our ticket. Inches over miles. Our given ratio, 1/4, is the same as 3, so 1/4 over 3. Now we want to find out if the cities are 2 1/4 inches apart, how many miles would they be in actuality? Cross multiply, I get 1/4 x is the same as 6 3/4. I'm dividing by 1/4 on each side to isolate x. Find out that x would really be 27 miles. Number 4, solve for the variable. 14 is the same as 19 minus n. I need to get rid of that positive 19 by subtracting 19. I'd find out negative n is the same as negative 5, but again, I need a positive variable, so I need to isolate by dividing by negative 1 and find out that 5 is really n. And that makes sense. 19 minus 5 does give me 14. All right, same as we've been doing all week. Take about a minute and continue to just copy down and know those formulas for the end of the year test. Once you've done that, a little quick review. We're going to take these, we're going to cross multiply, solve for the variable. It's going to help us with today's lesson. So pause the video for about a minute or two. Go ahead and solve these. All right, now that you're ready, let's go over. First one, we get 180x is the same as 540, so I divided by 180 on each side, and I'd find out that it's 3, not 0.3. That should just be a 3. Second one, 2 times n, 2n. 6 times 72, 432. Dividing each side by 2, I'd find out that n is really 216. And last one, same thing, cross multiplying. 15 times a, 15a. 3 times 400 is 1200. So 15a equals 1200. Divide each side by 15, I'd find out a is really 80. Okay, we're going to use this today to look at some new probability questions. So up here, really called relative frequency, but just a fancy name for how do I take a small sample size probability and expand it to a larger group. So, a carnival owner is running a game. To win the game, they must spin orange. If 200 people play the game, about how many times would they win the game? And this is important because we want to find out how many prizes should this guy expect to buy to be the carnival owner. Well, I know that to win the game, there's one orange segment out of 8 segments. So that would have a 1 in 8 chance of winning this game. So it's the wins to the totals. 1 orange, 8 different options. But I want to see how many winners would there be if there was 200 players. So again, I could set up a ratio and a proportion, cross multiply and solve for my variable. 8 times x is 8x. 200 times 1 is 200. Divide each side by 8. And we'd find out that there would be approximately 25 winners if this was spun 200 times. Another one I'll model here for you, this one using a dice. So the first thing, a student is rolling a dice with the faces 1 through 6. So again, all I did, set up the dice so that I can interact with them. If the student rolls it 400 times, about how many times should the student roll a 4 or a 5? Well, the first thing is I got to figure out what's the probability he gets a 4 or a 5? Well, I know there's 1 4 and 1 5, so there's 2 numbers out of 6 total numbers. So I can say that there's a 2 in 6 chance of rolling a 4 or a 5. But again, I want to see how many times would it win, how many times would we get 4 or 5 out of 400 rolls? Again, I cross multiply. 6 times x, 6x, 2 times 400 is 800. 800 divided by 6 would mean that there's approximately 133.3 repeating winners. But again, we would probably just say round that down to 133. Again, take a second if you have to, copy down your notes. And last one here before we try a couple on our own. The chart below represents food choices for a 7th grade sports banquet. Based on the survey of the results, if there's 200 people coming to the school, about how many would be expected to choose spaghetti? Well, I know that spaghetti is an option in 7 people out of, well, I got to figure out how many people they even surveyed because this is definitely not 200. So the first thing I figured out, well, there's 26 people surveyed. They didn't have time to survey all 200 people, so they took a small sample size, and now we're going to just kind of theoretically and using probability try to decide about how many people would choose spaghetti if there was 200 people invited. Well, I know that 7 out of 26 people chose spaghetti. And again, I want to find out how many people I don't know chose spaghetti if there was 200 people. So if I set up my ratio, I make it a proportion, I cross multiply, I get 26x equals 1,400. Last step, divide each side by 26. We would get 53.8, or approximately 54 people that would end up choosing spaghetti. So again, we had to find out our given ratio, what's our given probability, and then just expand upon that. All right, for this, I would try a couple of these on your own, just like we've been doing all week, see how you're doing before we get into the bit.ly. I'd pause the video, take about 4 or 5 minutes, solve these 3 problems. All right, now that you're set, Students roll in a fair number cube. If the student rolls it 340 times, about how many times would he expect to get a number greater than 4? Well, it's talking about that number cube, so the first thing I did, wrote out the 6 numbers. And then I thought about it. We're looking for numbers greater than 4. Well, that would be 5 and 6. So 2 out of 6 numbers are greater than 4. But again, we want to figure out if we rolled it 340 times, how many people would win. Cross multiply, 6x equals 680. Divide each side by 6. We find out again there's approximately 113 times that would happen out of 340. Number 2, back to a spinner. Student must spin orange to win. If the game is played 450 times, how many winners would we expect? Well, again, there's 1 orange segment out of 8 segments, so I would say there's a 1 in 8 chance that I would land on orange. Now we want to see how many times would it land on orange if there was 450 spins. Cross multiply, we would get 8x equals 450. 450 divided by 8, we'd figure about 56 winners. And number 3, using the exact same spinner, how many times would we get green to be spun? Well, let's think about this. There's 2 out of 8 green segments, so a little bit different than orange, 2 out of 8. And again, we want to spin it 600 times. Cross multiply, 8x equals 1,200. 1,200 divided by 8 would be approximately 150 greens would land out of 600 times spun. Again, if you have any questions, let us know. Bitly, go from there. Again, show your work, separate sheet of paper, or if you'd like, in the space provided below or on the back.